Welcome to the Data Genius podcast. Sometime in the next few years, you are going to receive this highly personalized marketing email, or maybe negotiate a complex business contract, or, purchase a bespoke digital product. And the crazy part is, you'll be doing all of this with an entity that doesn't actually exist.
Yeah, and we aren't talking about like a frustrating customer service chatbot when you're trying to return a pair of shoes.
Right. Definitely not that.
No, we are talking about a billion-strong, invisible workforce that's just quietly wiring itself into the very fabric of the global economy. It's a fundamental rewiring of how digital labor actually functions.
Which is huge.
Exactly.
Yeah.
I mean, historically, our relationship with AI has been largely transactional, right? You type a prompt, you get an answer. It's a single-use tool. But the architecture of business is moving incredibly fast into this era of massive, autonomous, multi-agent systems.
Yeah, and the financial analysts have already coined this very dramatic term for the megatrend. They're calling it the agent supernova. So today, our mission for this deep dive is to synthesize a massive stack of sources to figure out how this invisible workforce is being built, how it operates, and why it's changing, well, everything.
There's a lot to unpack.
There really is. We're pulling data from financial newsletters, from MarketWise, enterprise architectural papers, some really detailed developer code labs from Google and AWS, and technical documentation from platforms like Supernova.io and Sambanova. We're going to explore how AI agents are now being designed to actually manage other AI agents.
The middle management AIs.
Exactly, yeah. We'll look at the underlying plumbing making that possible and how companies are desperately trying to prevent these autonomous systems from just hallucinating and destroying their brand identity.
The stakes here really cannot be overstated. If you're trying to understand the future of the internet or, even just the future of your own job, understanding how these multi-agent swarms operate is completely mandatory. We are moving from AI as a software feature to AI as foundational infrastructure.
So let's pinpoint exactly when that shift happened. Because according to our MarketWise sources, the starting gun for this entire megatrend fired in November 2025.
Right.
That was when this Austrian developer, Peter Steinberger, released an open source program called OpenClaw. And when you read the retrospective coverage of this release, it genuinely shocked the tech world.
Oh, it completely broke the mold. It changed what an AI application was supposed to look like. Because, prior to November 2025, if you wanted an AI to perform a really complex task, you built a massive monolithic model and just tried to teach it everything.
Cramming everything into one brain.
Yeah, exactly.
Yeah.
But OpenClaw was different. It was essentially an AI agent that could autonomously manage online payments. You can make restaurant reservations, send emails, and this is the most important part, it could spawn and manage other specialized AI agents to complete those tasks for it.
That's the part that really bends the mind for me. It's not just doing the work, it's acting as middle management.
Yeah, it's delegating. And the ability for an AI to act as a manager, handing off subtasks to other AI programs, analyzing their output, and synthesizing a final result without any human intervention, that is what sparked this entire revolution.
And the industry noticed instantly, right?
Oh, the reaction was immediate and highly aggressive. OpenAI acquired Steinberger for an absolute fortune practically overnight.
Wow. And then Jensen Huang, the CEO of NVIDIA, the company that is literally supplying the physical hardware for this entire revolution, he went on record calling OpenClaw perhaps the most important software release in history.
Yeah, which is a massive statement.
Right. When the guy selling all the shovels for the gold rush says someone just invented a totally new type of gold, you have to pay attention.
Absolutely.
But let's look at the sheer scale of what this means for the economy, because MarketWise lays out some math in our sources that is frankly staggering. So just to give you some context, the United States has roughly 342 million people. But the agent supernova trend is projected to introduce billions of AI workers into the global economy.
Billions.
Yeah. They are predicting a 100,000-fold increase in AI agents operating with almost zero human oversight over the next few years.
And when you introduce billions of digital workers into a system that is built specifically for humans, you don't just speed up the system, you break it, and you have to rebuild it.
Right.
To make this abstract concept a bit more concrete, let's look at this hyper-local example detailed in the sources running a restaurant.
I love this example. It really grounds all this high-level tech talk.
Yeah, it's perfect. So in the old paradigm, a restaurant owner might use AI to generate some catchy menu descriptions, right? Or maybe write a localized Facebook ad.
Basic generative stuff.
Exactly. But in the multi-agent paradigm, the restaurant's operational backend is run by a swarm of specialized digital workers.
Okay, so how does that look?
Well, you have one agent dedicated entirely to optimizing cooking schedules,
Hmm.
and it does this based on historical order volume and real-time weather data.
Oh, wow, weather data.
Yeah, like if it's raining, more people order delivery, so it adjusts the prep schedule. Then another agent handles the real-time accounting and ledger updates. A third agent manages staffing and payroll. A fourth is constantly monitoring inventory, literally checking the prices of tomatoes across multiple vendors, and automatically reordering supplies when the stock dips below this predictive threshold.
That is wild.
And finally, you have a manager agent whose sole job is to coordinate all these sub-agents and translate their constant stream of data into a simple, daily briefing for the human owner.
So the human owner just talks to the manager agent. They're just sipping their coffee, asking how the restaurant is doing, while the manager agent is orchestrating this massive, invisible symphony of supply chain and accounting bots in the background.
Exactly. The human is completely removed from the microtasks.
But when I look at that, I think about an analogy from our MarketWise source that paints a much more disruptive picture of this whole thing. They describe the current global economy as this elegantly set dining table. You've got hundreds of pieces of silverware, fine crystal, precisely folded napkins,
Right.
and all that represents industries, supply chains, protocols built over decades, representing literally trillions of dollars. They argue that the agent supernova isn't just adding a new fork to the table, it's a force pulling the entire tablecloth out from under all of it.
That's a great analogy.
So if we're introducing billions of these agents, are we just swapping out human accountants for digital ones? Or does this fundamentally break the physical infrastructure of the internet?
It absolutely breaks the existing infrastructure. That's why the tablecloth analogy is so precise. Think about how a human actually works. A human accountant at that restaurant might spend, 4 hours on a Friday afternoon reconciling the books.
Yeah, checking a few spreadsheets, sending a couple of
Right, they
emails.
click around a banking portal a bit. It generates a minuscule amount of network traffic.
Because human time is slow and sporadic.
Exactly. But these AI agents do not work on human time. They operate at the speed of light, and they do not stop. They don't sleep, they don't take weekends off, they don't get distracted.
Right.
The inventory agent isn't just checking tomato prices once a week. It might be pinging 100 different wholesale supplier databases every 5 minutes. It's negotiating bulk rates with other supplier-side AI agents in real time.
Wow, so they're just constantly talking to each other.
Yes, because they operate continuously, querying databases, scraping websites, communicating via APIs, they're going to generate an absolute explosion of internet and communication traffic.
So a single restaurant's backend, which used to generate maybe a few megabytes of traffic a day, is suddenly generating gigabytes of constant automated requests.
Precisely. Multiply that by millions of businesses, and the volume of data moving across our global networks will scale exponentially. The internet was built for human-to-human and human-to-server communication.
Not machine to machine at this scale.
Right, it was not built for an ecosystem where billions of machines are constantly shouting at each other 24/7.
Which means this isn't just a software revolution, it's a massive hardware and bandwidth crisis.
It is, and that is exactly why the financial sources in our stack point out that semiconductor and digital infrastructure companies are poised to benefit massively.
Right, because someone have to build the pipes.
MarketWise specifically highlights Marvell Technology, ticker symbol MRVL. They're a $76 billion semiconductor and data infrastructure firm. Companies like Marvell that build the physical optical switches, the networking chips, the literal pathways for this exploding data traffic, they are the ones laying the physical tracks for this new digital railroad.
So the software agents are the trains, but without companies expanding the tracks, the entire system just grinds to a halt.
Exactly.
Okay, that perfectly frames the massive macroeconomic and physical stakes of this trend. But I want to open up the hood a bit. If you're a developer or a CIO listening to this deep dive, how do you actually build this invisible workforce? We've talked about the idea of a swarm of agents running a restaurant, but let's dive into the actual architecture of how they are constructed.
Let's do it.
So to figure this out, we're pulling from a fascinating developer code lab from Google called the Agentverse, alongside architectural data from AWS Strands.
And the foundational concept that makes all of this possible across all these platforms is something called decoupled AI tooling.
Decoupled, meaning separated. Why is that the breakthrough?
Well, historically, and by historically I literally mean a couple of years ago, when engineers wanted an AI to do something complex, they tried to bake all the knowledge and capabilities directly into the AI model's training data.
Right.
So if you wanted the AI to know how to calculate advanced tax liabilities, you try to train the neural network on tax law.
Which sounds logical on the surface, you send the AI to school so it learns everything.
It sounds logical, but it creates a bloated, insecure, and ultimately very rigid system.
How so?
If the tax code changes, your multi-billion parameter model is suddenly completely out of date, and retraining it costs millions of dollars. Furthermore, you really can't rely on a generative model to do precise mathematics or securely access private databases.
Because they hallucinate.
Exactly. Neural networks are inherently probabilistic. They basically guess the next most likely word based on patterns. You do not want your AI guessing how to format a SQL query to your private customer database.
Right. A hallucinated database query could wipe out your entire customer list in a second.
It's too dangerous. So the modern architectural approach is decoupled AI tooling. You keep the core AI model relatively lightweight. Its only real job is language comprehension, reasoning, and logic.
Just the thinking part.
Right. Then you give it secure, heavily guarded connections to external, highly specialized tools. The Google Code Lab metaphorically refers to these tools as elemental fonts of power that the AI agents can draw from when they need them.
Okay, so the AI is just the brain, and the tools are its hands. But what actually connects them? How does a language model grab a tool?
That's the key.
The Google Code Lab explains that the bridge connecting the AI to these tools is called the Model Context Protocol, or MCP. And this is where it gets really interesting, because the Code Lab breaks down these MCP servers into two distinct architectural approaches, imperative and declarative.
And this distinction is absolutely critical for understanding how enterprises keep these systems secure.
Let's tackle the imperative approach first.
Mm.
The Google Code Lab uses these great gamified fantasy names to keep developers engaged, which I love.
They're very fun.
Yeah. They call one of their imperative tools the Nexus of Whispers, which is designed for calling third-party external APIs. And they call another the Arcane Forge, which handles internal custom business logic. But getting away from the fantasy names for a second, an imperative MCP server requires human developers to write strict, step-by-step code, usually in Python. Why is it so crucial to use step-by-step imperative code for these specific tools?
It all comes down to absolute control and error handling. When an AI agent needs to interact with an external system, say a logistics provider's shipping API or some custom financial calculation engine, the format of that interaction has to be flawless.
There's no room for guessing.
None. If the external API requires an authentication token in the header, a specific JSON payload structure, and a precise date format, a generative AI might get it right, say 95% of the time. But that 5% failure rate is catastrophic in an enterprise setting.
It's like having an assistant who is brilliant but occasionally writes down phone numbers backwards. You can't actually trust them to make the call.
Exactly. So by using an imperative MCP server, human software engineers write the exact, rigid, step-by-step Python code that acts as a secure bridge. The AI agent doesn't construct the API call itself.
Oh, I see.
The AI simply tells the MCP server, execute the shipping tool using this tracking number. That's it. The imperative MCP server takes that variable, structures the complex authentication, formats the payload perfectly, sends it to the logistics provider, catches any server errors, and then translates the response back into plain text for the AI to understand.
Wow.
It gives enterprise architects a foolproof, hard-coded safety layer.
So you're basically giving the AI a custom-built remote control with one big, clearly labeled button, rather than asking it to grab a soldering iron and wire the circuit board itself every time it wants to turn on the TV.
That is a perfect way to visualize it, yes.
But then we have the other side of the protocol, the declarative approach. The Code Lab calls this the librarium of knowledge, and it functions as a database toolbox. And what really stood out in the sources is that instead of writing complex Python code, this approach uses a simple YAML configuration file.
Right.
So for those listening who aren't software engineers, what exactly is YAML, and why is it better for databases?
Well, YAML stands for YAML. 8 markup language programmers really love their recursive acronyms.
They really do.
But essentially, it is a highly readable, structured way to write down data. It looks a lot like a simple bulleted list. You use it to declare what you want without writing the logic of exactly how to get it.
So if imperative Python is a recipe telling a chef exactly how to chop the onions and simmer the sauce step by step, YAML is just a menu where you point and say, I want the burger.
Spot on. And this declarative approach is highly efficient for structured data access, like querying a massive Cloud SQL database. Why is that? Think about the security risk of giving an AI free rein to write raw SQL queries against your company's proprietary database.
Oh, yeah. Total nightmare.
It's a massive vulnerability. It could drop a table, expose private data, anything. So instead, the database engineers write a declarative YAML file. This file securely defines the database connection and explicitly lists the exact parameterized SQL queries that the AI is allowed to use.
Okay, could you give an example of how that works?
Sure. For example, the YAML file might define a query called get customer history.
Okay.
The AI agent can say, run get customer history for user ID 456. The database toolbox automatically spins up a secure MCP server based on that YAML configuration, executes that one specific pre-approved query, and returns the data.
It's completely locked down.
It is infinitely safer because the AI never actually touches raw SQL. It can only pull from the specific menu of queries you explicitly declared in the YAML file.
Okay, so we've established how the tools are securely connected to the AI using MCP. We have our secure tools. Now, we need the digital workers to actually use them.
Right, the workflows.
Exactly. Both the Google Code Lab and the AWS Strands documentation outline 3 highly specific multi-agent workflow patterns that enterprises are using to execute complex business tasks. Let's break these down one by one, pairing the Code Lab's fantasy metaphors with their real-world enterprise translations.
Perfect.
First up, we have the sequential pattern, which the Code Lab refers to as the fire elemental.
Right, so the fire elemental or sequential pattern is all about strict, unyielding order.
Very linear.
Exactly. The output of one specialized subagent feeds directly into the input of the next. There's no multitasking here at all. It is a rigid assembly line.
So what does that look like in the real world of business?
A prime example is automated invoice processing for a large corporation. You don't want creativity here. You want pure precision.
Yeah, nobody wants a creative accountant.
Exactly. So step 1, an extraction agent receives a PDF invoice via email, uses its tools to parse the document, and extracts the vendor name, amount, and line items. It then hands that structured data to the next agent.
Okay, step 2.
Step 2, a validation agent takes that data and uses a declarative MCP tool to query the company ledger, ensuring this invoice hasn't already been paid and that the vendor is actually approved.
Right.
Step 3, a payment agent issues the funds through a secure imperative banking API. And step 4, a reconciliation agent updates the accounting database to reflect the cleared payment. It must happen in that exact linear order, and each agent only knows how to do its one specific job.
Clean, linear, and ordered.
Okay.
Just like an assembly line.
Yep.
Next, we have the parallel pattern, which the Code Lab calls the water elemental. The documentation beautifully describes this as a fan-out, fan-in pincer attack.
The water elemental is where multi-agent systems achieve massive gains in sheer speed. In a parallel workflow, you have a master delegator agent that takes a complex problem, breaks it into independent pieces, and delegates those tasks to multiple subagents to execute simultaneously.
It fans out the work.
Yes. Think about a complex customer onboarding process at a major financial institution.
Okay, usually a very slow process.
Very slow. When a new customer applies for an account, they submit a ton of data. In a legacy system, a human or a single computer program would process this sequentially, making the customer wait. But in a parallel multi-agent swarm, the system fans out immediately.
So everyone's working at once.
Exactly. One agent runs a background credit check through an external API. A second agent simultaneously runs image recognition to verify the uploaded driver's license. A third agent concurrently queries the internal CRM database to see if this customer already has an existing profile. They are all working at the exact same time.
And then the fan-in part.
Right. Once all 3 independent agents return their findings, a final merging agent, the fan-in phase, synthesizes all that disparate data to make a final approval or denial decision in seconds.
It's the ultimate delegator. It takes a process that might take a human an hour and crushes it into 3 seconds because the digital workers can split the labor flawlessly.
Exactly.
And finally, we have the loop pattern, the Earth elemental. The Code Lab refers to this as the siege engine.
The Earth elemental is fascinating. It's designed for iterative, continuous pressure.
So it doesn't stop.
Right. The sequential pattern runs once. The parallel pattern fans out and merges once. But the loop pattern repeats a specific sequence of tasks indefinitely until a highly specific condition or threshold is met.
Where would a business actually deploy a siege engine?
The perfect enterprise example is digital campaign optimization. Let's say a company is running a massive digital ad campaign across multiple platforms. An Earth Elemental Loop agent is deployed.
Okay.
It analyzes the current ad spend and the real-time conversion data. It makes a micro adjustment, say shifting 2% of the budget from Instagram to TikTok based on some early signals.
Right.
It then pauses, uses its tools to check the key performance indicators like the click-through rate over the next hour. If the target KPI isn't met, the agent loops back to the beginning, analyzes the new data, makes another micro adjustment, and checks again. It is relentless, grinding optimization.
And according to the AWS Strands data in our sources, utilizing these multi-agent collaboration patterns, these fire, water, and earth workflows, improves success rates on complex business goals by up to 70% compared to a single monolithic AI trying to do it all.
Which is astounding. A 70% leap in success rate is a generational leap in software efficacy. It absolutely proves that specialized, coordinated intelligence is vastly superior to generalized intelligence.
It is an incredible stat. But let's pause here for a second, because when I read about this loop pattern, alarm bells just started going off in my head.
I can guess why.
Yeah, like if we compare these different architectures to human management styles, the sequential pattern is the factory floor manager. The parallel pattern is the high-efficiency startup CEO delegating tasks. But the loop pattern, it sounds like a manic, obsessive employee who just refuses to go home until the job is absolutely perfect.
That is a very apt characterization.
So what happens when it goes wrong? If an agent is constantly querying external databases, running complex AI models to analyze data, and looping back to do it again, couldn't a broken loop be completely disastrous? Like, what stops an AI Earth elemental from getting stuck in an infinite loop, getting confused by a contradictory data point, and racking up a massive bankruptcy-inducing cloud computing bill overnight?
This is one of the most vital questions an enterprise architect has to answer, and it is a very real, very legitimate fear for chief information officers everywhere.
I would be terrified.
You should be, because AI inference, the actual act of a model generating a response, costs money. API calls cost money. An infinite loop isn't just a software bug in this paradigm, it's a financial hemorrhage.
So how do they stop it? How do they pull the plug?
The AWS Strands documentation provides the exact solution. Modern orchestration frameworks do not simply let agents loop endlessly based on their own judgment.
Okay, good.
Enterprise architects implement incredibly strict, hard-coded guardrails completely outside the AI's control. They set hard parameters in the underlying Python code.
For example?
For example, they will write a parameter like max handoffs equals 2 or max iterations equals 3.
Meaning the agent can only try 3 times no matter what it thinks.
Exactly. Even if the agent believes it is just one step away from solving the optimization problem, the orchestration framework cuts it off at 3 iterations, period.
Wow, just a hard stop.
Furthermore, they implement strict temporal execution timeouts. They might set a hard stop at 300 seconds for the entire swarm.
Just 5 minutes.
Right. If the overarching goal isn't met within that 5-minute window, the underlying system forcibly halts all execution. It terminates the MCP connections, and it flags the process for human review. The laws of the system are written in deterministic code to prevent runaway probabilistic inference bills.
Okay, so the guardrails are in place. The CIO can sleep at night knowing the AI won't spend $10 million optimizing a Facebook ad by accident. But this leads to a logistical question for me. If an enterprise has hundreds of these specialized fire, water, and earth agents, these sequential, parallel, and looping workers, and they are all utilizing decoupled tools via MCP, how does the enterprise actually coordinate them?
It's a huge coordination problem.
Yeah, how do these distinct programs even know they exist on the network? This brings us to what the sources call the command locus and the underlying mechanics of agent-to-agent communication.
Right, because to manage a swarm of this magnitude, you need a master conductor. The Google Code Lab calls this the summoner agent, while enterprise literature generally calls it the master orchestrator.
Summoner agent is much cooler.
Definitely cooler. But the crucial thing to understand about the summoner agent is that it does absolutely zero actual work.
It's purely management.
Purely management. When a human user or an external trigger inputs a massive problem into the system, the summoner agent analyzes the request, breaks it down into subtasks, determines which specialized sub-agent on the network is best suited for each task, and delegates it.
But how does the summoner agent know what the other agents can do? Like, if the HR agent gets an update to its model overnight, how does the master orchestrator know about its new capabilities?
This is achieved through the agent-to-agent protocol, commonly referred to as A2A.
A2A.
Yeah, and the A2A protocol is what elevates a standalone AI script sitting on a server into a discoverable microservice on a corporate network. When an agent is built and exposed via A2A, it generates something called an agent card.
And the Code Lab has another great name for this. They call the agent card a spirit sigil.
Naturally.
But technically speaking, what is an agent card?
Technically, it is essentially an open API specification for an artificial intelligence.
Okay, let's break that down, because open API specification sounds like really dense developer jargon. To use an analogy, is the agent card sort of like an AI's LinkedIn profile?
That is a phenomenal analogy. Yes, exactly. An open API specification or an agent card is a standardized, machine-readable document that tells the master orchestrator exactly what skills are available for hire. It lists the agent's name, a description of its purpose, the exact data inputs it requires to function, and the exact format of the outputs it promises to deliver.
So it's like a restaurant menu. Give me $5 and a tomato, and I will give you a bowl of soup. The master orchestrator reads the menu and decides if it wants to order.
Exactly. And this concept of decoupled service discovery is absolutely brilliant for enterprise IT, and is why this architecture is scaling so rapidly right now.
Why is that? Why is it so crucial?
Imagine you are a CIO. You have a massive multi-agent system running your entire customer service department.
Okay.
6 months from now, a brand new lightning-fast open-source model is released, and you want to swap out the brain of your primary refund processing agent to save money or increase speed.
Makes sense.
In a tightly coupled legacy software architecture, replacing a core component like that might break the entire system. The dependencies are tangled.
We pull one string and the whole sweater unravels.
Right. But with A2A and agent cards, the system is entirely modular. As long as your new, upgraded refund processing agent publishes the exact same agent card, meaning it still accepts a customer ID as an input and outputs a true or false refund decision, you can completely swap out its underlying neural network.
Oh, I see.
You can change its MCP tools, or you can move it to a different cloud provider entirely. The master orchestrator doesn't care how the agent does its job. It only cares about the contract defined in the agent card.
That's incredibly powerful.
It is. It creates an incredibly resilient, flexible system where components can be upgraded seamlessly without a single hiccup in the broader workflow.
It is literally plug-and-play digital labor. You can fire and hire new digital workers in milliseconds, and as long as they follow the open API specification, the company just keeps running. It is fascinating.
It's the future of IT.
But as we scale this concept up, we start to hit some very human walls.
We do.
It's one thing to have agents silently processing invoices and checking inventory databases. Math is math. But when we apply multi-agent swarms to creative, forward-facing, subjective departments like marketing, design, and brand identity, things get messy fast.
Very messy.
We have to talk about the threat of brand drift and how modern platforms manage what our sources call ground truth.
This is a critical pivot in our deep dive. We are transitioning from internal logistical efficiency to external brand perception. When an AI interacts directly with the public, the rules change entirely.
Completely.
The architectural papers we reviewed explicitly identify a severe bottleneck in autonomous marketing, which they term context fragmentation and brand drift.
Let me paint a picture of what context fragmentation means in reality for the listener. Let's say you are a massive premium tech brand and you have deployed a swarm of marketing agents to generate personalized emails for 1 million different customers.
Okay.
The AI agent writing the email might be a linguistic genius. The copy is persuasive, the logic of the pitch is sound, and it's perfectly tailored to the user's buying history.
Sounds great so far.
Right. But because generative AI models inherently operate in isolation and learn from the entire internet, they tend to hallucinate visual styling when left to their own devices.
They get creative.
Exactly. So this brilliant marketing agent generates the HTML for the email, but it uses a slightly neon shade of blue instead of your trademarked corporate navy. It uses a chaotic, off-brand font it learned from a random blog somewhere. It completely ignores your company's strict white space and padding rules.
The output is technically functional, but stylistically it's disastrous.
Exactly. It's like having a genius, top-tier salesperson who shows up to a high-stakes client meeting wearing a brightly colored clown suit.
Yes.
The message they are delivering might be brilliant, but the visual presentation makes the brand look cheap, untrustworthy, and chaotic.
And brand trust is arguably the most valuable asset a modern enterprise possesses. You cannot automate your marketing if the automation degrades the brand.
Which makes sense.
And this exact problem is what the platform supernova.io was built to solve.
We saw supernova.io heavily referenced in the technical documentation, so how do they fix the clown suit problem?
Supernova.io operates as a central registry, a single, unalterable source of ground truth for an enterprise's entire design ecosystem. It manages design tokens, component libraries, typography rules, and brand standards.
Wait, what exactly is a design token?
Think of a design token as a tiny atomic piece of brand identity translated into machine-readable code.
Okay, how so?
Instead of telling a developer or an AI to use our corporate blue, you create a design token called Color Brand Primary, which maps exactly to a specific hex code, like hashtag 0055FF.
Oh, I see.
Supernova takes all the subjective human vibes of a brand, the colors, the spacing, the border radiuses, and translates them into structured, centralized metadata.
Okay, so the company defines its absolute soul in supernova.io. How does that actually stop the AI from hallucinating the styles, though?
By utilizing those exact MCP endpoints we discussed earlier. Supernova.io essentially acts as a declarative librarian of knowledge for brand identity. It feeds this product context directly to the active marketing and coding agents in real time.
In real time?
Right. When a front-end coding agent is tasked with generating a landing page, or a marketing agent is generating an email, it isn't guessing the hex code for your brand's blue. It queries the supernova.io MCP server, pulls the exact human-approved design token from the central registry, and injects it directly into the code.
That's brilliant.
It guarantees that every single asset generated by the swarm is not just structurally sound, but stylistically and legally compliant with the brand's exact identity.
It provides rigid guardrails for creativity. And this urgent need for unified context across AI agents was heavily echoed at the Config 2025 conference. Our Supernova blog source covered some massive announcements from Figma at that exact event.
Yes, Figma is positioning itself right at the absolute center of this workflow.
They introduced several AI-driven tools. There was Figma Make, which allows developers to do AI to prototype generation straight from symbol text prompts, and Figma Buzz, which generates AI-branded content specifically tailored for marketing assets.
Right.
But beyond the product drops, the keynote talk that really stood out in the sources was a conversation between Dylan Field, the CEO of Figma, and Andrew Bosworth, the CTO of Meta.
That was a fascinating discussion.
It was. They were discussing the intersection of spatial computing-like augmented reality headsets and AI generation. And their core thesis was that as AI begins generating content across entirely different mediums, from flat web pages to 3D virtual environments, these emergent platforms absolutely require underlying systems that can scale brand consistency flawlessly.
And if we connect their thesis to the architectural models we've been discussing, it perfectly explains why Supernova.io's approach to providing scoped context is so vital to enterprise survival.
Scoped context, as opposed to global context.
Exactly. This is a huge distinction. One of the biggest mistakes early developers made was trying to dump their entire corporate design system, their entire code base, and all their marketing guidelines into every single agent's memory prompt.
Just giving them everything.
Yeah. They gave the AI global context.
Which sounds like a massive recipe for information overload.
It is. If you dump a 500-page brand manifesto into the prompt of an AI agent whose only job is to write the subject line of an email, the agent gets confused by all the noise.
Right.
Furthermore, feeding that much data into a model for every single action consumes an enormous amount of computational tokens. And as we established, tokens cost money.
So how does scoping fix this?
By scoping the context through a platform like Supernova.io, you curate the data.
Okay.
A front-end web development agent building a React component needs deep context on CSS variables, shadow rendering, and interactive component states. It receives a heavily scoped package of technical design tokens.
Makes sense.
Conversely, a marketing copywriter agent doesn't need to know how a button hovers in CSS. It needs context on brand, voice, tone, and prohibited vocabulary. Supernova routes the correct scoped context to the correct agent.
You give the agent exactly what it needs to do its job and absolutely nothing it doesn't.
Precisely. This dramatically saves on token usage costs, which prevents those spiraling cloud bills we talked about, and it significantly improves the accuracy of the agent by removing irrelevant noise from its reasoning process.
Okay, we have our brand identity locked in. We have our specialized agents connected via MCP. Now, I want to take you down into the engine room of these marketing pipelines. I want to show the listener exactly how these multi-agent multi-agent systems execute complex, enterprise-grade marketing in real time.
This is where it gets really mathematical.
Because when you read the technical documentation on how these marketing swarms actually make decisions, they aren't just guessing based on a vibe, they are calculating. The underlying math driving this invisible workforce is absolutely fascinating.
It is a profound shift from intuition-based marketing to mathematically rigorous execution.
Let's walk through the pipeline step by step. First, we have content research.
Right.
Traditionally, a human marketer might open Google, type a few keywords related to their product, scan the first page of results, and just start drafting an article based on what they think sounds good. But how do modern research agents handle this?
They operate on a completely different plane of depth. Modern research agents don't rely on simple keyword lookups at all. They utilize iterative web browsing combined with sandbox file analysis.
Meaning what exactly? Like, what does that look like?
Meaning the agent acts like a tireless, hyper-focused academic researcher. It is given a broad directive, say, analyze the market for sustainable running shoes.
Okay.
The research agent uses an MCP tool to execute hundreds of search queries simultaneously. It downloads the top 50 competitor articles, PDFs, and white papers into a secure digital sandbox.
All at once.
Yep. It then runs deep reasoning loops, analyzing the semantic structure of all those documents to build comprehensive market profiles. It identifies exact topical gaps, questions consumers are asking that competitors haven't answered yet, before a single word of draft content is ever written.
It maps the entire battlefield before making a move.
Exactly.
And when it's time to make a move and write that content, we get into SEO, production, search engine optimization. This is where the math and the sources truly blew my mind. The AI writing agents don't just sprinkle keywords into paragraphs and hope for the best.
No, they don't.
They use a metric called cosine similarity.
Yes. Cosine similarity is a foundational concept in advanced semantic search and natural language processing.
Okay, for those of us who haven't taken a high-level statistics or linear algebra class recently, explain how an AI uses cosine similarity to write a blog post.
Sure. To evaluate search intent and ensure an article ranks highly on Google, the SEO agent mathematically models semantic similarity. It maps highly ranked competitor pages and targeted keyword clusters into multidimensional vector spaces.
Okay, let's pause and visualize that. When you say vector space, you mean the AI takes a word or a concept and translates its meaning into a series of numbers like coordinates on a massive multidimensional map.
Exactly. In a vector space, words with similar meanings are physically grouped closer together in the math.
Right.
The classic example in natural language processing is that if you take the coordinate vector for the word king, subtract the vector for man, and add the vector for woman, the resulting coordinate lands almost exactly on the word queen.
That is wild. The math inherently understands the relationship between the concepts.
It does. It's beautiful.
Okay, so the agent has mapped the target topic into these coordinates. Then what?
It takes its own generated draft article and maps that into a vector as well. Let's call the draft article vector A. And let's call the target topic cluster what consumers actually want to read, vector B.
Okay, vector A and vector B.
The agent then calculates the dot product of vector A and vector B and divides that by the product of their magnitudes.
So it's measuring the angle between the 2 points on the map?
Precisely. The formula measures the cosine of the angle between the two vectors. If the angle is 0 degrees, the cosine is 1, meaning the draft article perfectly aligns with the semantic intent of the target topic.
Wow.
If the angle is 90 degrees, the cosine is 0, meaning the article is completely irrelevant.
So the AI agent literally rewrites its own draft over and over, recalculating the dot product each time, trying to mathematically force the angle closer and closer to 0.
Yes. By mathematically maximizing this cosine similarity metric, the SEO writing agent ensures that the content covers all the necessary semantic nodes to rank highly on search engines. It completely removes the human guesswork from SEO and replaces it with geometric proof.
That is it's incredible. But modern marketing isn't just long-form SEO articles. It's rapid response social media, too. It's capitalizing on fleeting trends. And the sources outline a fascinating multi-agent social scheduling pipeline designed for this exact purpose.
Yes, and this is where we see the water elemental parallel pattern in full effect.
Right. You have a specialized listening agent whose only job is to continuously monitor platform APIs, LinkedIn, TikTok, X, Instagram scanning for spikes in specific hashtags or brand mentions.
It's just sitting there listening to the static of the internet.
Exactly. When it detects a statistically significant trend related to the company's industry, it instantly routes that telemetry data to a drafting agent.
And because of the supernova.io integration we discussed, the drafting agent doesn't just guess what the post should look like.
Right, it has the guardrails.
It instantly pulls the exact visual specifications from the brand's design library. It generates the copy, aligns it with the required design tokens, and creates an on-brand social media post responding to the trend in a matter of minutes, while a human social media manager might still be asleep.
It's fully automated, hyper-responsive marketing, and we see a similar level of dynamic, instantaneous generation in the email personalization pipeline. Traditional email automation, the kind most companies use today, is fairly basic.
Very basic.
It's just a static template where a mail server pastes a customer's first name into the greeting. Hello, John.
Which consumers have learned to ignore entirely. It doesn't feel personalized anymore at all.
Exactly. But agentic systems use tools like Supernova's Supermail exporter engine to do something completely different. The marketing agents synthesize completely custom, responsive HTML layouts from scratch for every single user.
Based on data.
Right. If the data shows that a specific customer historically clicks on large, visual product grids rather than text-heavy descriptions, the agent pulls the visual grid component configurations from Supernova on the fly, assembles the HTML, and sends a bespoke layout just for them.
It is atomic design rendered at the absolute moment of delivery, based on real-time behavioral data.
And finally, we arrive at A/B testing, which has always been the holy grail of digital marketing. Marketers constantly test two variations of an ad to see which performs better. But human marketers often look at a dashboard, see that variation A got a few more clicks than variation B, and call it a winner based on, like, a gut feeling. These multi-agent systems don't use gut feelings, they use the Z-score test statistic.
This is where the analytics agents truly flex their mathematical muscles.
Oh, absolutely.
An analytics agent ingests real-time conversion telemetry from a live campaign. It performs rigorous, automated hypothesis testing to ensure the results aren't just a statistical fluke.
So how does the math work here?
The agent takes the conversion rate of campaign variation 1,
Mm-hmm.
let's mathematically define it as P1, and it takes the conversion rate of variation 2, P2.
Okay, T1 and T2.
It calculates the difference between P1 and P2 and divides that by the standard error of the combined distribution.
So it's calculating exactly how many standard deviations apart the two results are.
Exactly. This mathematical proof generates a Z-score. If the Z-score crosses a specific threshold, usually corresponding to a 95% confidence interval, the analytics agent determines with absolute statistical certainty which campaign variation is the winner.
Wow.
It then autonomously shuts down the losing campaign and routes the remaining budget to the winning campaign. No human bias, no waiting for a weekly marketing meeting, just pure statistical optimization executing in real time.
I have to pause again because I look at all this math, the cosine similarity, the vector space dot product, the z-scores, and I feel a profound sense of awe mixed with just a little bit of terror.
I completely understand that.
Because if modern marketing is literally just AI agents optimizing cosine similarity against other AI agents' z-scores, does the human element completely vanish? Are we just turning business, creativity, and connection into a sterile mathematical battle of algorithms fighting other algorithms in the dark?
It is a very valid existential concern for anyone in a creative field. However, the architecture we've explored today actually prevents that sterility if it's implemented correctly.
How so? Because the math seems entirely devoid of emotion.
The math is devoid of emotion, but the math does not define the objective. It only defines the execution.
Okay, unpack that for me.
The math ensures efficiency, reach, and statistical validity. But remember the context layer we talked about. Remember the design tokens, the brand voice guidelines, the strict product rules managed in central registries like supernova.io?
Right.
That entire context layer is curated, debated, and approved by human beings. It contains the company's soul, its visual identity, its sense of humor, its tone of voice.
Ah, I see. So the humans define the parameters of the game, and the AI just plays it flawlessly.
Precisely. The agents are executing the mathematical strategy at scale, but the parameters of that execution remain distinctly human and deeply aligned with the brand's core identity. You are using algorithms to scale human ingenuity, not to replace it.
The humans set the vibe, and the math scales it to billions of interactions. I love that framing.
It's a good way to look at it.
But scaling this level of complex mathematics requires unfathomable horsepower. Let's move into the final section of our analysis and talk about the physical computing infrastructure required to run millions of these agent prompts per second and the absolute chaos currently unfolding in the AI market.
The computational demand of multi-agent systems is astronomical, and it's fundamentally different from traditional AI usage.
Right, because earlier we talked about how a single user request might trigger a whole swarm of agents.
Exactly. When a human user makes a single request to an agentic system, that system might issue thousands of hidden prompts behind the scenes.
Just to answer one question.
Yes, because the agents are brainstorming strategies, they're critiquing their own work, summarizing data, and looping through revisions.
The sources refer to this as test time compute, right? Letting the AI think before it answers.
Yes, and our sources note an incredible phenomenon here. Allowing these agents to engage in self-reflection and internal critique lifts their success rates by double digits on complex benchmarks.
Without even changing the model.
Without ever needing to fine-tune the underlying model. The longer you let them think, the smarter they appear to be.
That's wild.
But that thinking requires massive hardware throughput. It is measured in tokens per second, and because swarms issue thousands of prompts, the inference cost must be incredibly cheap, or the business model just collapses.
The sources highlight a couple of heavy hitters stepping up to provide this infrastructure. First, on the model side, we have Amazon Nova Micro.
Right.
This is a text-only model specifically engineered for speed and cost. It streams over 200 tokens per second with sub-second latency. It is explicitly designed to be the lightweight brain for these swarms, keeping inference costs low so developers don't go bankrupt letting their Earth elementals loop.
And on the physical hardware side, the sources spotlight Samba Nova, a company that recently hit an $11 billion valuation following a massive $1 billion financing round.
Wow, 11 billion.
Yeah, and they are taking a totally different approach to the hardware itself.
How so? Aren't they just using GPUs like NVIDIA?
No, Samba Nova builds reconfigurable data flow units, or RDUs. While GPUs were originally designed for rendering graphics and adapted for AI later, RDUs are designed specifically from the ground up for the flow of AI inference data.
Interesting.
Their hardware is capable of running massive, state-of-the-art open-source models at staggering speeds.
The numbers in the documentation are wild.
They really are. For example, Samba Nova can run the massive 671 billion parameter DeepSeek v3.1 model at up to 200 tokens per second.
That's huge.
Even more impressively, they are running the Minimax M2.7 model at an astounding 435 output tokens per second, which they claim is 3 times faster than competing cloud providers.
435 tokens a second.
Yeah. When you are building a swarm that requires thousands of micro decisions per minute, you need this exact type of specialized high-throughput heavy machinery.
It is the Industrial Revolution all over again, but the factories are digital. Now, speaking of this massive boom in infrastructure and startups, I have to bring this up because it provided a moment of genuine hilarity when we were reviewing the source stack for this deep dive.
Oh, I know where you're going with this.
The AI market is moving so incredibly fast and so much money is pouring in that companies are literally running out of names.
The naming collision in our sources was definitely noticeable.
Noticeable is an understatement. Just look at the documents we reviewed for this specific deep dive alone.
It's a lot.
We have the agent supernova megatrend itself, coined by the analysts. Then we have supernova.io, the design system platform we discussed. Then there is RC Supernova, which is a highly capable 70 billion parameter small language model.
It keeps going.
It does. Then we reviewed documentation from Supernova's AI with an S, which is a unified workspace for large language models. Then there is Supernova AI without an S, which is a completely different data analytics tool. And finally, we have a company called Supernova Digital Marketing and Advertising. It is a naming collision of epic proportions.
It really highlights the absolute frenzy of the current market. Everyone is trying to grab the most explosive, futuristic-sounding name.
It's exactly like the early 2000s .com boom. Back then, every single company slapped an E or an I in front of their name or added .com to their logo to secure venture capital funding.
Just add an E and get $1 million.
Exactly! I swear, if you want to secure VC funding in 2026, you don't even need a product. Just name your holding company Supernova.
It is humorous to see the marketing trends converge so aggressively. But if we look a bit deeper, the naming phenomenon is actually an incredibly apt, poetic metaphor for what is happening.
How so?
Think about what a supernova actually is in astrophysics. It is the explosive death of a massive star.
Right.
But that explosion isn't merely destructive. The extreme heat, pressure, and energy of a supernova nucleosynthesis are required to forge the heavy elements like iron, gold, and uranium that are necessary for the formation of new planets and ultimately new life.
So the old world has to explode to create the building blocks for the new one.
Exactly. That is exactly what is happening to the global economy right now. The old paradigms of static software, manual data entry, and intuition-based operations are exploding under the weight of this new technology.
Yeah.
But the energy from that explosion, the massive influx of capital, the rapid development of RDUs, the creation of decoupled MCP architectures, is birthing entirely new industries, new ways of working, and a completely new digital ecosystem.
That is a phenomenal, profound way to look at it. The agent supernova isn't just an ending, it is a violent, chaotic beginning. Which brings us to the end of our deep dive today. But before we wrap up, I want to leave you with a provocative thought.
Let's hear it.
We spent this time breaking down how companies are setting up these master orchestrator agents and how they negotiate with other agents using the A2A protocol. Think about the implications of that for a moment as this scales globally.
Oh,
What happens when a highly optimized buyer agent from company A, programmed with a relentless earth elemental loop to maximize profit, engages with a seller agent from company B with the exact same directives? Will they reach a logical equilibrium? Or will they get locked in a relentless millisecond by millisecond infinite loop trying to outcalculate and outnegotiate each other?
an unstoppable force meeting an immovable object.
Exactly. Will we start seeing algorithmic flash crashes in everyday B2B negotiations? Will an entire supply chain stall because two stubborn AI agents refuse to break their loop and compromise on a fraction of a cent? It is a wild, uncharted frontier out there, and the rules are being written in real time. If you enjoyed this, please take a moment to like the episode, invite a friend to listen, and leave a comment sharing your thoughts on where this invisible workforce is heading next. And make sure to subscribe for future episodes so you never miss an update on the data shaping our world. Until next time, keep your context clear, your agents aligned, and stay curious.